or asking a question that I think I want to make sure that I share with everybody, the little dialogue that was going on. I really do value Tom Tipton and his contribution to this class. Now, he's not here every night because, well, to tell you the truth, he's not getting paid to be here during this time. But he is an integral part of this course, and I admire him greatly. And I will send him, you know, a copy of the exam so he knows, you know, what's on it. I'll probably send him the same rough copy that I sent Linda, but I will be sending that to him. And so someone asked, will he know about this? And my answer was, well, he will, but not this second. He doesn't, because I sent that to Linda like 2 minutes before class started tonight. And so, you know, there wasn't a lot of lead time with that. Okay, so let's go in, and we're going to now do some content work. And Linda, I'm going to ask you, we work till 8:40. So I'm going to ask you, how long do you think you want to talk for your little agenda item there called, you know, talking about content or whatever that is? How long do you want? And I will, you know, plan accordingly for that.
Probably like 10, 15 minutes. I want to leave a little bit of time for questions, just in case anyone looks at the study guide and isn't sure what I'm talking about. So that should be good, though.
Okay, so, and is this study guide something that you sent to me too, or?
So I actually logged in as you, and I posted it under the syllabus tab like 30 minutes before class.
Okay, so that's great. And what I will do is I'll make sure that Tom Tipton is aware of that too. And so, you know, Tom will have that, and so on and so forth. And thank you. Okay, so I'm thinking about 15 minutes. Okay, and you said 10 to 15, and so that's what I'm going to allow. And I don't know if it'll be 10 or if it'll be 15, but it's something in between that. Okay. Now, I think these problems that we're going to be doing are going to be useful for you. That doesn't mean I'm asking exactly things that are going to be on the test. But here are some questions. And by the way, I don't know if Linda ends up speaking about this or not whenever she talks about, you know, the study review or you know, whatever she's going to say to you. We didn't practice that. I'm sure whatever she will say will be useful and it will be fine. But I struggle a little bit knowing how to even count things, because like I made up a problem that had M parts, A through M, and Linda suggested I might want to think about renumbering that, and I might end up renumbering that. But anyway, here is a question that deals with the Chicago Bears. And the reason I'm asking this question is that there will be questions where there is information that is in the Blackboard tab that you have to go and fetch the information in order to do the problem, okay? And I'll say, oh, like here, I'm telling you, go find, you know, the Chicago Bears file. And by the way, this in your syllabus tab is called the Bears roster, okay? And Linda, I think what I'm going to do with this, which is different than what I've often done, but I think I'm going to ask some questions, and then I'm going to pause, and students can volunteer to answer them. And if the students don't answer them in, you know, what I consider is a timely way, I won't let that get too uncomfortable. I'll ask you the question, okay? So Linda's going to be pretending she is a student, but I would encourage you to maybe think about having multiple tabs open. And Linda maybe can tell you how to open a multiple tab, but I would encourage you to get this file and try to do it. So anyway, Linda's going to then, and by the way, we're going to get the file, and the very first question that I'm asking is, what college produced the most bears? And these days, you can play professional basketball and never play college basketball, but it is almost unheard of for somebody to play professional football and not play college football somewhere. So anyway, I'm going to ask Linda to take over and find the file, throw up the Excel spreadsheet, and then Linda, after you throw up the spreadsheet, I'm going to ask the question, okay? So Linda's doing that. Linda, take over. So change this and go find the file and throw it up there, and then I'll ask a question for the students and perhaps you. So Linda's
Okay.
going to Blackboard, and she's found it there. Okay, now, one of the things that I did, and this actually is a Bears roster, okay, but for example, there's a person on the Bears named Allen Robinson, and he just got a huge contract because he had a very good year, and he's kind of an all-star receiver. And so he has a big contract. But you see what happened on the database I was looking at, it had a picture of Allen Robinson tied in intimately with his name and things like that. So I just said the heck with that, and I just got the number. So this column A, that's the number of the bears. But when I'm asking which bear, you don't have a name. If there was a name there, you could tell me, oh, it's Allen Robinson or something like that. But you do have numbers. So the unique identifier here is number. Now we have different things. So for example, you can see number 10 is Mitch Trubinsky. I happen to know that. Okay, so he is from North Carolina, and you have that. But that's the line that talks about Mitch Trubinsky. And Kathy, I'll be with you in just a minute, okay? And you got positions and everything else and so forth. But now the very first question that I ask, and that after I answer Kathy's question, I'm going to ask you, the students, how would you go about answering this? And I'm asking someone to volunteer and tell us your idea. Now, don't ever be afraid of volunteering, because I don't ever write something down and said, oh, Susie Smith gave a lame answer. I don't do that. This is all about learning. But gee, if I ask this question on an exam, you would have to deal with it. So I want to hear what Kathy has to say, ask first, and then I'm going to pose that question. Go ahead, Kathy.
I'm wondering, how do you open it? Linda has it open as an Excel, and when I open it from Blackboard, which I just did, it only opens it as like a PDF or a screen. It's not Excel. I don't know how to do that, and so it's going to take
So
me a
did
long
you
time.
open the Bears roster Excel
Yep.
sheet?
Yep, I tried to, and it opened it on Blackboard as like just a page on Blackboard.
Well, I'm almost thinking that we're not going to debug that here. Okay. Now, I think it is important, Kathy, that you do figure out what's happening there. But that Linda's showing you the one she clicked on and she got Excel. Now I have no idea what kind of platform you got and everything else, and I don't want to spend a lot of time right now. And it's not because I don't love you. I do love you as a student, okay? But I want to I want to focus on the content right now. So we're going to just and we do
And
have
Kathy,
to.
we can work on troubleshooting this during the GSG tomorrow as well.
Will
Okay.
will it be important to be able to copy that data, or can I just copy and paste it? I mean, without this entering the data into cells.
You should be able to copy and paste it into an Excel spreadsheet if it's not opening up correctly, so we'll get that figured out tomorrow, okay?
Okay.
Nicole has her hand up, and Nicole, I do want to hear your question, but I also want to get back and ask my question about this. But go ahead. Oh, are you volunteering to answer the question, Nicole?
I was volunteering to answer.
Hey, great. Okay, excellent. I really appreciate that. Okay, so how would you approach that problem of finding out which college contributed the most bears?
Personally, my first thought was to go to the colleges and put them in alphabetical order. And
Well,
then
that's a brilliant answer. And then you can just run down and see which column happens. Now, you do want to be careful, and Linda will be careful when she sorts that, because she doesn't want to lose those numbers or anything like that, so she's sorting everything. And Nicole, that was a great answer. Thank you for that. And so Linda is doing exactly that. So she's doing a custom sort. We'll just let her do it. Linda, you can talk if you want.
Okay, so I'm doing a custom sort for the colleges. And let's see. Just do it A to Z, and there we go. So really, I'm just looking for what appears the most. So it looks like Georgia appears a few times. And let's see. So far, the number to beat is 4. And I'm not seeing any more than those 4, aside from all these from Tennessee, but those aren't quite the same. So
Yeah,
I
those are
believe
different.
that Georgia is our winner.
And Georgia's our winner, and Nicole was 100% correct in how to do that. And Nicole, it looks like your hand's still up, and maybe it's up for some other reason or something. No, she put it down. Okay, so that was good. All right, so Emily has a question or a comment here. Go ahead, Emily.
Would you guys just be able to repeat what the question was?
Sure. The question was, which college contributed the most bears?
Okay.
And
Thank you.
Emily, there was somebody, Jenna. Okay, she has a question too. Go ahead.
Can Linda, can you show again how you sorted it from A to Z?
Yeah, absolutely. So all I did was highlighted everything. So starting with the headers and going down, because you don't want to lose how the rows are attached. So then from here, I went under sort and filter, and I did a custom sort. So you're sorting by the colleges, and this just gives you the different names of the columns. And we are sorting based on what's in them, and because there are words, then we're doing it A to Z. So then just hit OK, and it'll sort it for you.
Okay, thank you.
Kathy has a question. Go ahead, Kathy.
Can you explain another way to solve that other than just counting to like try and figure them out if you weren't able to
There is no other way to solve this other than counting.
So I mean,
Now you could say that you're going down and you're making little tick marks, but the way that Nicole said this was a very efficient way to solve this, because otherwise you're going down and say, well, there's one from Alabama, so put a little tick mark there, and then you say there's one from Arizona, and you could go that down. But doing it the way that she did it, sorting it, is exactly the way we that you really should do this. And again, what I'm indicating is that you want to reach out. There is going to be data that you're going to be reaching in and getting, and you're going to be doing some things with it, and we're exercising some of those skills now.
So Kathy, there is a function to use in Excel to count certain things. But honestly, when you're using data sizes that are between like 0 and 60, basically, then it's honestly recommended that you just kind of eyeball it. Like when you're using bigger data sizes, then we can get into more kind of weird Excel functions that you can use. But for this, then just eyeball it.
We don't have time to teach all the weird Excel. I mean, that's whole courses that are like that, and that's not what we're about. Go ahead, Kathy.
I was just going to say, if for some reason, because other times I have been able to open Excel and or I can open Excel, but I mean open the Blackboard, the things you have listed in Excel, it opens up. And for this one, if it isn't, and if this happens on the test, I was asking if there's any other quicker way than just writing a list out of every single.
Well, here's what I think. I'm optimistic that you and Linda will resolve whatever software incompatibility you have, and we'll do that. And as far as what happens on the test, Linda and I are experienced pilots and things like that, and COVID sucks. Okay, so we have to, we deal with it, but we do what we have to, and we will find a way. And I'm going to land this plane, and I'm going to land it safely with people. So we'll do what we have to. Yes, Emily.
So I'm looking at the study guide while we do these problems. So my
that's not what we're doing right now, Emily. So hold that question until we return to that part of the agenda, please.
Oh, sorry.
Because
not review the midterm?
Well, we're in the middle of working a problem right now, okay? And also, I mean, you know, we could have a in-depth discussion about what are the prospects for the College of DuPage opening in the fall, okay? And that would be a fascinating discussion, but it's not what we're talking about right now, okay?
Well, my
And we're
question
all,
is just going to be what type of problem this was, like what topic is it?
So this would be considered your sorting data.
Okay.
all right, and somebody asked what question, and we were answering the question, what colleges did they come from? Linda, go back to the chart, please. Okay, I say, what's the deal with the heights? So Linda, go back there to the spreadsheet. And Sierra has her hand up, and I hope she's answering the question, but we'll see. So I'm saying, what's the deal with the heights here? So Sierra, are you answering the question?
Yep.
Okay, go ahead, please.
Is it the number of the month, like June 00 would be 6 feet, and then when you see May, would that be 5'11"?
Yes, it would. Excellent. And this is a formatting issue. And by the way, when you do things in real life, you will run up against this. And in fact, they did have the heights listed, but they had it in terms of feet and inches. Okay, so we have this. So and she nailed it. That's exactly right. And so we have to put numbers in there. Now, fortunately, there's not a million bears. There's only 50 some, I think, on this roster. So Linda, we need to fix that. And Linda, we're going to fix that just with a brute force thing. So why don't you add a column that is called, yeah, insert one there. Okay, and Linda's just going to go through and she's going to put, and by the way, I'm looking ahead because I know we want to have this in terms of inches. So Linda, you're going to be putting inches in there. Go ahead, please.
Okay.
Yes, Kathy, Linda's doing work while you're asking your question. Go ahead. And Linda, I can't see you anymore. There.
Okay.
Yeah. Yes, Kathy, Linda's doing work.
Will we, if I try to find a way to download everything you already have listed in the Blackboard, that's an Excel. If I try to download that already to my own Excel files, will you be adding a lot more files for the midterm, or will everything kind of be from the data that's already there?
No, it won't be the data that's already there. It'll be new stuff. I'll probably have it in a folder that's called midterm data.
Okay.
So Linda's working through this, and fortunately, you know, a bunch of these people have the same. Like there's a bunch of people that are 6 feet tall and things like that. So anyway, she's getting all those inches, and she'll be done with that soon. Okay. Now my question was, you see, that was just formatted incorrectly, but that is something that you have to run across. And Linda's just brute force pounding through there, and she's going to have them all done very soon. But now the next question that I am asking you is, I think, and I'm not looking at the PowerPoint slide right now, but I think what I'm going to do is I'm going to ask you to come up with a measure that's going to be called weight density of a bear. And so what that is going to be is it's going to be a function that's defined to be the weight of the bear in pounds divided by their height in inches. And the bigger that number is, the denser the bear is. And so what we're going to do is we're going to be doing a calculation in Excel. And I didn't write any study guide for this, but yes, it is important. You may be asked to do a calculation in Excel. So that's what I would call this next kind of thing. And Linda, did we get them all?
Yep, we did.
All right, so this is height in inches, good. And then Linda, we need a thing probably in front of ages there, or in front of age, there's going to be a column. And why don't you go and Linda actually see what the question is? And Sierra, I'll be with you in just a second. Oh, well, look here. If we define the weight density of a bear to be, I got Sierra and Hannah in just a minute. So we define the weight density of a bear to be weight per inch of height. Who is the densest bear? Sierra and I lost track of who the other person was. Sierra, go ahead.
It was Hannah after me. I just have a quick question for height. Isn't 6 feet 72 inches? I'm confused on how we're doing the height.
6 feet is 72 inches. 5 feet is 60.
Yep. I can just not do math.
Oh,
so
that's okay.
ignore me for a minute.
I was just confused that I was doing this. Okay, thank you.
Let's see. Just give me 1 second. I'll fix this.
Did you do that all the way along?
Yep, I did.
Well, you see, it's great. She did it consistently wrong, so we're okay. Because that's easily fixed. And thank you, that was a good call. And Hannah, was that your comment as well? Hannah, was there another question or was that it? Okay, so Hannah's, maybe it was the same question, I hope so. Okay, or she was making the same comment. Okay, so now we're going to calculate the density of the bear. And my connection can't show the whole thing, and my internet's a little bit flaky right now.
That's fine. So we're just doing weight divided by height, right?
That's right. So keep talking, and we'll just assume people can see what you're doing.
Okay, so I'm doing the weight divided by height. I'm not using any absolute cell references because I do want it to just go straight down. And I drag that down, and there we go. Now, if we're trying to find the densest bear, then I do want to sort these based on the density.
Now,
so I'm highlighting.
Kathy has a question right now, Linda. So let's hear Kathy's question.
Okay.
Linda, why did you not use the number signs? Isn't it doing the same? Don't you want it dividing the same way down the whole thing?
So I do want it to divide down the whole way, but I want you to look at the formula that I put in. So when I go down, because I didn't use the absolute cell references, it's going to change the cells for every single row.
Okay.
So you can see here that it's doing F5 divided by E5 in this row, but the next one it would be F6 divided by E6.
Okay.
Okay.
All right, now, and so Linda is going to sort those, and she'll find out who is the densest bear. But this time she's sorting it by what, Linda?
So now I am sorting it by density. And we want smallest to largest, so that's fine. So looking at the densities, I go all the way down to find the largest density, which is about 4.57, and that is bear number 96.
And bear number 96, it looks like it's a defensive tackle. That looked like a D to me. So anyway, 96 is the densest bear. But now we have one more question, and the one more question on the PowerPoint slide, I think, is who is the most extreme bear relative to density? And Linda, I'm going to ask this question of you. You can be extreme in two ways. How can you be extreme in two ways?
So it could be extremely low or extremely high.
And how would you approach this? Well, I guess my clue is there. This is going to have to do with the z-score, isn't it?
It does. So I'm going to need both the mean and the standard deviation.
Yep. So go ahead and talk about that. And again, see, this is reviewing a whole bunch of stuff. That's why I like this problem. Okay, so Linda, go ahead.
First, I need to find my mean. And we are doing this in reference to the densities. So I'm doing equals average, open a parenthesis, and highlight my densities. So I can close my parenthesis and hit enter. And then I also need a standard deviation.
And Linda, this is the roster of the bears as of that day, so this is a population.
Okay, so I use my population formula for standard deviation. And then once again, I just highlight the densities. Close my parenthesis and hit enter. So I have my mean and standard deviation. So now what I would do is just find the z-scores of both the highest and lowest value for the densities. And since I already have that sorted, then I can really easily compute that here. I mean, I guess I could find the z-scores for everything though. So hit your density minus the mean. So in this case, my mean is in cell O2. So I would be doing $O, $2, close my parenthesis, and I'm dividing that by $O, $3. That was a 0. There we go. And then I hit enter, and I'm going to drag down those z-scores. So my highest z-score is about, my lowest is negative 1.66 approximately. So if I'm looking for the one furthest from 0, then that would be my highest, which is the 96 again.
But it would not have to have been just worked out that way, Linda, yes?
Yes, that is absolutely correct.
Okay, and Kathy has a question. Go ahead, Kathy, please.
2 questions actually. Will the standard deviation or the z-score formula be on the grace notes?
It is in
Yes.
the grace notes.
Okay, and as far as the z-scores, when you just sorted them, how did I missed how you sorted them? Did you sort and move all of the data the same way with the sort and filter again?
So the z-scores I didn't actually need to sort because the densities were already sorted. So since the z-scores were in reference to the densities, then the z-scores will also be sorted.
Oh, okay.
Now, one student asked exactly what checkbox is this, and Emily, I want to say something, and then I want to call on you. But a student was asking a question earlier, and they said, well, exactly what problem is this? Which line item on the study guide? Well, I haven't looked at Linda's study guide, but I bet this was a half a dozen of those items, because I bet Linda was talking about the standard deviation. I bet she was talking about the mean. I bet she was talking about sorting things. I bet she was talking about going and getting data. I bet she was talking about z-scores. So you see, I chose this problem and constructed this problem to review a whole bunch of things. It's not just checking one thing, it's maybe checking several things. And Emily, I wanted to say that before I forgot it, but now I'd like to recognize you. Go ahead, please, with your question.
Okay, thank you. So I actually have 2 questions. My first question, really quick, was how do we know which standard deviation formula to use?
Well, you notice that I interrupted and I told Linda what was happening here. And I'm thinking about a specific problem, but I also tell you on the exam.
Okay, so it'll tell us whether it's like a population or something different.
That's right. And I'm not at, and that's kind of a subtle thing. And I'm also going to tell you, even if you use the wrong formula, it's normally not a huge numerical difference, and I probably would count it right anyway. But in fact, she's showing you, Linda's showing you that this isn't going to be there's not going to be a Tinker's Dam worth of difference between these two, actually.
So that S was for sample, right?
Yeah.
Yes,
So this is what you would have had for your standard deviation if you used the sample formula.
Okay.
This is what you would have gotten if you used the population.
Okay.
So I mean, that's really not going to affect your answer that much differently.
And I would count either one of those, just fine. You said you had a second question.
Yeah, Linda, can you just show how you got the z-score again, please, just really quick?
So for the z-score, all I'm doing is taking your density
Okay.
subtracting the mean,
Mm-hmm.
and then dividing all of that, so I put that in parentheses, by your standard deviation.
So why is it divided by 3? Or am I
It's being divided by P3, which is where your standard deviation is.
Okay, that makes sense. I was confused. I was like, where did we get the 3 from? Okay.
Yeah, that's just where the cell is.
Okay, thank you.
Yep.
Okay, Linda, let's go back. I think we maybe did that. And by the way, I have taught this course actually much. In fact, Linda said I should quit teaching this course and teach other things. And I actually, I do teach other things too. Linda actually should have my job, but we have to work through and make that happen. Anyway, the thing that I was going to say is that well, anyway, there's several things that covered, and you know, and I think that was a good problem to review, to cover much of that. Okay, now this next, in fact, Linda, go back to the previous one. Let's make sure we answered. I think we answered all that. We did. Oh, I know what I was going to say, Emily. I'll recognize you in just a moment. The time that I did teach this course before, though, I used the 2016 Chicago Cubs roster for a problem once upon a time. And it turned out that Kyle Schwarber, who is a chunky baseball player, was not the most extreme Cub, because it was Carl Edwards Jr., who was a very skinny, very tall pitcher, who at that time was the most extreme. So it's not always the heaviest, it could be the lightest. I think we answered all that. Okay, and so I think we had Emily first, and then we had Caitlin. So Emily, did you have a question? Or
My hand was still up from the last time. I just put it down. Thank you.
Okay, Caitlin, do you have something here? Go ahead, please.
Yeah, when we're answering questions, how do you want us to round it? Like to the nearest 10th, to the highest whole number? How do you want us to round these numbers when we're
Well, first of all, don't round off till the end of the problem, okay? And then we actually have talked about some conventions. Z-scores get rounded to the nearest 100th position, and means normally get rounded to one more decimal place, and means and standard deviations get rounded to one more decimal place than what you have with the data. And I'm going to say is probably give me you know, several of the numbers, and I'm not going to be worrying and arguing about your rounding. So just keep all the information that Excel gives you, and that's good. And by the way, they talked about not using calculators. You have the world's greatest calculator here with Excel. And so, you know, using Excel will allow you to do all those calculations. Okay, now we're moving into a different kind of problem now. And by the way, that last one was not just one kind of problem. That was kind of a mega problem. There were many things that were being discussed there. But here on this one, and I call this 28, 29, and 30. I don't know where the 30 went. But anyway, I'm going to read number 25, and then I'm going to ask the students, what kind of a problem is this? Okay, so here I go. Please listen to my words, and it's there to read. In the classic legal case of Whittis versus Georgia, a jury pool of 90 people was supposed to be randomly selected from a population in which 27% were minorities. So this was in a community where 90%, or you have a jury pool of 90%, and the jury pool was selected from a population in which 27% were minorities. Among the 90 people selected, 7 were minorities for the jury pool. Find the probability of getting 7 or fewer minorities if the jury pool, and I'm going in and out here a little bit, Linda, if the jury pool was randomly selected. Okay, we will find the probability of getting 7 or more. Is the result of getting 7 minorities significantly low, And what does this result suggest about the jury selection process? So I'm going to pause for a moment and ask if any students want to volunteer, and there's no penalty for getting it wrong. What kind of a problem is this of the things that we studied? Yes, Caitlin, go ahead, give it a shot.
Is it probability?
It is a probability. What kind of probability? Either you're a minority or you're not a minority. So what kind of probability is this? Yes, Lori.
Binomial?
That's a binomial probability problem. And so this is a binomial probability problem. The probability that you are a minority is 27%. The probability that you're not a minority is, let's see, that would be 73%. So you're one of the others. We're selecting 90 people, and only 7 were minorities. So we're going to find the probability of getting 7 or fewer if the jury pool were randomly selected from that population. Okay, so Linda, I'm going to turn this over to you and just let you talk about this for a while. Go ahead, please. This has to do with binomial probability distribution.
Okay.
And I don't know if that's on Linda's study guide or not, but it probably ought to be. Yes, Emily.
Could you quickly explain how we would be able to identify that it's a binomial probability problem?
Either you're a minority or you're not
No.
a minority. That's what this problem is all about. When you read it and think about it, that's what's happening. And we did, a bunch of examples. You could say, I voted for Donald Trump, or I didn't vote for Donald Trump. I am Catholic, or I am non-Catholic. So there's a lot of ways it can do this, but there are 2 outcomes. And so I knew that, and Emily, I'll be with you in just a second. There were 2 outcomes. There was a fixed number of trials, 90, and there were a fixed number of things that we're calling successes, and we have probability functions that are there. So this, and you might find this not as satisfying, but it does satisfy everything that we talked about a binomial distribution. Emily, go ahead, please. Emily's hand went down, so maybe it really wasn't up. Kathy, what's up?
Are you saying that, to clarify, the binomial means that there are only 2 choices for every selection?
There are two outcomes. Either you're a minority or you're not a minority.
So if a question has, if it had 3 options, it wouldn't be binomial?
If there were 3 outcomes, it would not be binomial, it would be something else. But again, the binomial distribution was one of the things that we studied. And I'm not 100% sure, I don't remember about LSAs, but let's go ahead. So look at the characteristics of a binomial distribution. A binomial distribution has 2 outcomes. Go ahead, Linda.
Okay, so we're talking about the probability of getting 7 or fewer. So those possibilities are 0 through 7. So the first thing I'm doing is listing those out just so we know which scenario that we're actually talking about. Now next, if you guys actually did look at the study guide that I posted, then I did include this formula on it at the very end. So we're doing the equals binom.dist. And to do that, we're putting in the number S, so the number of trials. So in this case, well, the number of successes that we want is going to be our number of minorities, right? The trials that we have are the 90 people being selected, so comma 90. The probability of success we got was 27%, so 0.27. And the last number we're going to put is 0. So close that parenthesis and hit enter.
Now
and from here, sorry, what?
I was going to say that's very close to 0, isn't it?
Yes, it is.
Yeah. Okay, and Kathy, we're going to call on you in just a moment, so relax.
So I've dragged those down so we have the probability of each outcome.
And what are you going to do with those probabilities then?
So the
Linda?
first thing they're asking is find the probability of getting 7 or fewer. So for our first question, then all I'm doing is adding those up. So this is my probability, and I believe I can write that just as a number, and we'll get some more decimals in there.
So Linda, is that very likely to happen?
No, not at all.
Okay, now I want to, okay, so that's not very likely that you get 7 or fewer. It's possible, but, and Linda will tell you how often that happens out of a million tries in just a minute. But Kathy, what is your question?
2 questions. First of all, how did you know for number of minorities, wouldn't it be that 27% would be what you're looking for? Why did you put 7? I thought it was the probability.
So it's the probability of getting 7 or fewer. So we looked at the probability for each individual outcome. So this is getting 0 minorities. This would be getting 1 minority, 2 minorities, and so on.
Out of all 90?
Yeah, exactly. So the only reason I only listed the first 8 possibilities is because those are the only ones that they're concerned about.
And so for instance,
and the 27, Kathy, and I may be answering your question further, but you see the 27% says, but anybody you pick, there should be a 0.27 probability of getting a minority if you're picking the people randomly, and that means there's a 73% chance of getting that. And Linda just declared that to be the probability of success, so that's why that's there. Now, if that wasn't your question, go ahead and ask your question some more, but that I was trying to tie that to sort of the way you asked that question, so go ahead.
Oh, well, I'm a little confused because I'm wondering why you couldn't take, like for instance, 0 minorities. Why couldn't you take 0 divided by 90, and that would be your percent, the chance for getting that? I guess I'm confused. Like if I read this question, I would think it's a lot simpler. I wouldn't know to jump to a formula. How, like what would be the, I guess what would be the keywords, or what would be a hint that I would be using that formula?
Well, I'm going to say what I'm probably saying something similar to what I said before, and then I'll ask Linda to comment on it. But you see, what makes something binomial is there are 2 outcomes. So you're a minority or you're not a minority. There is a fixed number of trials, 90. And there is a number of successes, and either you're a success, or you are not a success. And Linda, if you want to wade in here and say some more things, that's fine. But that was my shot at answering that.
So I think the words find the probability of getting 7 or fewer should kind of ring the bells of, okay, well, maybe I need to create this probability distribution. Because you're not just talking about the one outcome. And the way that they're sort of discussing this problem, then it's not just 7 over 90, because you're picking more than just that one person, right? It's not that out of the 90 people selected, there are 7 minorities, and what is the probability of just that, of selecting 1 minority from the 7, right? It's that you're doing each of these outcomes and figuring out the probability of each one happening. That way we know the probability of the whole chunk by adding those up.
All right, Emily has a question, and I'm going to ask Emily about her question, please.
So, Linda, on your study guide that you sent us for the binomial distribution formula, it says number correct. You said it differently, so what do you mean by number correct?
So number correct is the number of successes. So in this case, the number of minorities. It's the number of things that you want to happen.
Okay, sounds good.
Okay. Yes, Kathy.
Could we also solve this the other way we had worked on, where you would say, like, the first the first time would be 27% for the first choice times 27% times 27 for each of the selections, 7 times? Would that also be a legitimate way to solve this?
No, because what you were doing is that question that you're talking about was if you get 27, you see, you're saying, oh, it's independent, and that's okay for it to be independent, but you're saying, what's the probability of the first 7 people you pick are all minorities? So that's going to be 0.27 times 0.27 times 0.27 all the way down to 0.27. Doing that, that would be like the lady tasting tea. But
Right.
this is a different problem because we're doing that selection for each of 90 different people. Okay.
Now, Kathy, you are kind of on the right track, though, but the problem is you're not including the combination in that formula.
Yeah,
So
I
if you
agree.
did include the combination, so in this case, for the first one, it would be like 90 choose 0. Then it would be 90 choose, actually, this would be 90 choose 90 times, let's see, 83 choose something. It's if you were making a select number of committees, right?
So we could do that 90 times, or we just couldn't do that formula at all?
So
When
you
you
would
were
need
picking,
to use that formula if you were to do this, but it would take you so much longer.
because when you're picking 90 people and 7 minorities, those 7 minorities could be the first 7 you pick, they could be the last 7 you pick, they could be scattered all about. So you'd have to count all of those things, and the binomial probability, does that for you. Now, one of the things that happens in this review is this is helping you realize some things that you maybe know well and other things you know less well. So this review might uncover some things of you saying, hey, I don't know that part so well, so I'm going to go back and I'm going to watch that video again, or maybe those videos again, and things like that. And Linda, that's not very likely. So what would someone conclude then about this jury selection process?
So something probably happened to rig it because they definitely should have gotten more than 7.
That's right. And in fact, we learned that the mean of a binomial probability distribution is n times p. That was one of the formulas that we do. So Linda, would you calculate n times p?
So 90 times 0.27, that would give us
Yeah.
24.3. So that's what we should have expected it to be around.
You expect it to be around 24 people. Instead of that, you got only 7. And so, that's way low, and that's what we got. Yes, Kathy.
Could you also explain those numbers in the probability of X? Are those aren't percentages? What does that mean? 5, 1.6?
So those are probabilities. They're just not written as a percentage. They're written as a decimal.
And that's times 10 to the minus 13th, which is a very tiny number. Linda, let's go back and let's look at another one, because I'm thinking that some of these others might be similar. Actually, not here. So that's not where we are. So let's advance just a few more slides. I know what I'm looking for. Keep going. There. One back, Linda. And Kathy, I'm going to recognize you in just a moment, okay? But let's look at these problems, and I'm going to read them. If 8 adult smartphone users are randomly selected, find the probability that exactly 6 of them use their smartphones in meetings or classes. And above that it says, assume that adults are randomly selected. 54% of them use their smartphones in meetings. Okay, well, here's what's happening. This is also binomial, because either you use your smartphone or you don't use your smartphone. You're picking these independently. You're randomly selecting the people. And in number 28, you're doing in number 28, you're doing 8 choices. Okay, and in number 24, you're doing that. Linda, do problem number 23 together. And Kathy, I do want to hear what you have to say, but we're going to do problem 23, which is also another binomial probability. And so, Linda, that's 10, and Linda learned what she needed to know with that. Okay, so Kathy, what is your question?
On the midterm, if we prepare and we do the best we can to be ready, and we get to a problem where we just have no idea what formula or what to use, and we just attempt to use one that's not correct, will there be any credit or half points done for attempting to solve something but using the wrong standard deviation or the wrong formula, or is it just, 100% it is or it isn't for each problem?
Well, first of all, I would, and you said several things there, and I'm picking out a couple of things to respond to because I think it's useful to do that. If you read the first problem and you say, I don't know how to do that first problem, then I would go directly to problem 2. Okay, and I would work through, that way. There will be, if you leave the answer sheet blank, there's going to be no credit for that problem. If you put down an answer that's pretty correct, there will be a lot of credit for that problem. If you put down an answer that's wrong, but you turn in work that has credit, that will earn partial credit. Now, I'm not going to be getting more granular than that right now, but it will be, done in a fair and equitable way. But you also said something else, and that is, I prepared well for this exam and I did my best. And if you do that, you should be proud of yourself, and I would be proud of you too. I'll be proud to know that you made that kind of effort and things like that. So that's the best answer I have for your question. Linda, what number did I say there?
I believe you said 23.
Okay, so Linda's going to talk about 23. Go ahead, Linda, please.
Okay, so they're saying
it's a little different. Go ahead.
So find the probability that at least 8 use their smartphones in meetings or classes. So the options here are 8, 9, or 10, right? So these are my values for x. So then finding p of x, then I can use that same formula from before. So equals that binom.dist, open a parenthesis. My number of successes are these values of x. The trials are going to be 10 because there's 10 adult smartphone users randomly being selected. The probability of success is what they told me in the description, so that 54%, so 0.54. And then once again, I put a 0. So I close my parenthesis and I can drag this down. Now, since we're finding the probability that it's at least 8, then I'm going to add all these up.
At least 8 means 8 or more.
Yes, it does. So this would be my answer.
Yes, Kathy.
How did you know to do, like, from the question, I would use 8 or 10. How did you know to include 9?
Because it says at least 8. So not exactly 8 like it says in the previous problems, not fewer than 8 like it says in 24, but at least 8. So 8 is my minimum.
So, and what made you, how did you know to use that formula, binomial distribution, in the
Because either they use their phone in classes or they do not.
And is that formula on the Grace Notes, or we need to memorize that to enter it in?
The Excel formula is on your study guide. The actual formula will be on the Grace Notes, just not the Excel formula.
Emily, do you have a question?
Yes. So if the problem would have said fewer, would we have done 0 to 8?
Yes.
So if it said
Oh, no.
fewer than 8, then it would have only gone 0 through 7.
Okay. Fewer than 8.
Linda, can you walk us through the formula again? What to enter?
Yeah, absolutely. So binom.dist, the first number that you're putting in is the number of successes. So normally I just make a chart. So we have the number of successes listed out. The next number that you have is the number of trials. So that's how many total things that are being selected here. So 8 for the first one, 20, 10, 12, right? Because that's the amount that's being randomly selected.
Okay.
Now the next number that you're using is the probability of success. So in this case, a success is somebody actually using their phone in a meeting or class, right?
I'm not sure. I don't
Since
understand.
this is the number of people who are using their phone in meetings or classes.
Right.
So the probability of success is going to be 0.54, since using their phone in a meeting or class is what we're counting as success.
What was the 0?
So that's the thing that we want to happen. The 0 is just what you have to put at the end as some weird Excel thing.
Oh, okay. So the 54 is the percent.
Yeah, so that's why I put the 0.54.
Okay, so we have Paula and we have Lori in that order. Paula first, please.
So Linda, we always put a 0 there, no matter if it's a binomial. We're doing this formula, we'll always put the 0 at the end.
For
yes,
what we're
you will
doing in
always
this
be putting
course,
the
it's
0.
yes. It's yes, yes. And
that's why on that study guide, I just put a 0 at the end. You don't need to worry about that.
And Lori, you had a question also, I think.
I had the same question. I was just curious if that 0 changed or if it's the same thing. So she answered.
Always a 0.
And again, one of the things that will happen as we're going through this review is there might be some problems that you run across and say, wow, I really want to watch that video again, that talks about these matters. Okay, Linda, I am watching the clock pretty closely. Let's go back to the PowerPoint show, and we'll see what else we might be able to talk about. Oh, and this says, what is the mean and what is the standard deviation? Now we have formulas for the mean and standard deviation, don't we? Okay. Now this distribution, and actually I was talking about each one. Let's just do that for number 23, Linda. And then Paula, we will get to your question, but just a moment, if you will, because Linda's going to say, what was the mean for that one? And go ahead and talk, Linda, a little bit, and then I'll call on Paula when you're finished. Go ahead.
Okay. So to get the mean for a binomial distribution, then what you're doing is just n times p. So in this case, the number of things that we're taking are 10. So I'm doing 10 times, and my probability of success was given in the description, 0.54. So I multiply those two numbers and I get 5.4. So that is my mean. Any questions on that?
And then we're going to do the standard deviation.
Linda,
okay. So to get the... Sorry, what was that?
I have a question. Why did you do a different formula for the mean for that problem? Why did you do a multiplication?
Instead of the average formula?
Right.
Because for this problem, I don't have data listed out.
How would we...
So because I don't have data, I only have the number of trials that were done, and I have the probability of a success, right?
Right.
So because I don't have data to highlight, then I can't use the average formula. So I have to use the formula to get the mean for a binomial random variable.
Now, was that Paula talking?
No, it's Kathy.
All right, Kathy, I called on Paula first. Now you're second in the queue, okay? And I'm not being mean when I'm saying that, but I'm trying to have some order here. And Paula's hand up was first. Now that might have been Paula's question, and maybe, you know, it's answered now. Paula, what was your question?
So when Linda started doing the problem, I knew that we needed 8, 9, and 10, but in some of your videos, you were doing like from 0 to 10, but then you just focus on 8, 9, 10. Would we get points off if we do it how you did it on the video?
You will get points off if you don't give me the right answer, and you can do it either way. You can do it different ways. In the video, I was actually usually constructing the entire table, not just the piece of it that I was using. But then if I were doing this problem in the video, I don't think I did this one, but who knows. But I would have highlighted 8, 9, and 10 and added those up. But you see, either way, Paula, you would have gotten the same answer. Okay. And now Linda's going to show you the standard deviation, and then we'll go back to Kathy to see if there is more this. And the formula that is in the Grace notes, and it was in the videos about the standard deviation of the binomial distribution, is it's the square root of NP times 1 minus P. Back to you, Linda.
Okay, so all I'm doing right now is just typing in the square root function, and inside of those parentheses, then I'm doing n times p times 1 minus p. So in that case, that would be 10 times 0.54, and 1 minus 0.54 is 0.46. So I close that parenthesis and hit enter, and this is my standard deviation.
Okay. Now, Kathy, you had a question, and I may have interrupted you in mid-question. And again, Kathy, I was not being rude, but it's just Paula had her hand up first, and I have to, you know, maintain that kind of order. So go ahead, Kathy, it's your turn. Go ahead and finish your question, please.
No, I'm just still confused how we would know how would we know it's a binomial and not to do that diagram, the tree diagram sideways where we multiply the percents? Because when we did that for like in the tea drinking, there were 2 choices there, but we did it completely differently. How would that?
So you could make the tree diagram, but you're not taking into account the different orders that the people could be chosen. So you would have to go through every single branch of that tree and find where 8 people got it correct, where 9 people got it correct, where 10 people got it correct, and then add up those probabilities.
No, I mean, couldn't you just do, if it's 54% each time, couldn't you do 54% times 10 or to the 10th power?
That would be assuming that all 10 would do that. So for the very last one, then that's pretty much the only one that you could do where that would work with that formula. But in all the other cases, then you need to include the combination, because if you're choosing 9 who use their phone and 1 that doesn't, well, what place are you choosing to put the 1 that doesn't?
I don't know. I'm very confused. Okay. That's fine. I'll just keep looking into it on my own. Thank you.
Well, and again, I'm about ready to turn this over to Linda to talk about you know, the study guide and things like that. But just a comment. No, yeah, I mean, when we say that, we're not saying you're on your own or anything like that. But what we are saying is that I think what's being highlighted here is that this binomial distribution is something that is worth you know, focusing on some more. And you might have more questions, but things will become clear as you go and focus on this. And again, I'm teaching you a very good course. I'm teaching you a lot of material because that's what I'm supposed to do. But at the same time, you have a lot of support that's available. Tom Topol and Linda and so on and so forth. And my office hours that happen, you know, I have 10 office hours a week. And so, you know, there is a lot of help available, and this is not going to be until a week from now. So if there's some things that you're still working on, I'm not surprised at that at all, but you're not on your own. It's just, yeah, maybe I'll watch the videos again. Maybe I'll go to guided study group. Maybe I'll go to Jim's offices. Maybe I'll go to see Tom Topol, you know, some of those things. So you're not on your own. But I promised Linda 10 minutes, and she has 9 minutes. So Linda, why don't you talk about your study guide or your reaction to my test or whatever, and I will listen because I haven't even looked at this note yet.
Okay. So I did post this in the syllabus tab, so this is available for you guys to look at. And let me bring this up real quick. So basically what I did was I went through the midterm that was sent to me. I wrote out the big topics, and for anything that seemed like you guys maybe struggled with it a little bit in class or weren't quite sure about what to do, then I tried to give hints or kind of notes about like different problems that we've done in class that kind of might ring a bell on what these topics are. So I mean, some of this stuff, then you'll see me write like, what's the probability that someone answered yes, given that they're a man? So I mean, just things to try to ring a bell. And then especially the how to find a linear regression equation, then it seemed like a lot of people had trouble with that. So I wanted to refresh you guys with the Excel formulas, a little bit on what it actually means, what you're getting, and kind of how to walk through that problem. So this should give you a lot of guidance, at least, for what to expect, what you should be able to do. Little notes, important questions to be asking yourself as you're studying, and then another Excel formula. So are there any questions, things that you feel like I should have mentioned but didn't?
Okay, we have Kathy first, and then there's someone, and it's Caitlin. So it's this order this time. It is Kathy and then Caitlin. And Caitlin, I'll remember that. So you'll be second in the queue. Go ahead, Kathy.
Linda, in your GSG review, will you be going through, will you have things prepared, or are we supposed to come with our questions, or are you going to work through like all of these kind of in order?
So, I mean, we only have the 50 minutes, so I'm just going with whatever you guys bring me. It's whatever you guys want to talk about.
Okay, and this, your review guide, this will not be allowed as a Grace Notes?
This will not be Grace Notes. This is for you to use in the next week to help you get ready for the exam.
Caitlin.
Yeah, Linda, I'm not going to be able to make the GSG that you have on Friday. Can I ask, is there any way you can record it and post it so that I can, well, we could watch it over the weekend?
I will try to figure out how to do that.
Okay, thank you.
Yes, Emily.
Linda, when are your GSGs?
So the GSGs are typically on Mondays and Wednesdays from 5 to 6 p.m. Now, because of the midterm, then I am doing an extra GSG this Friday at the same time, 5 to 6. So you'll be using the Monday link that I sent out in the email.
Okay, sounds good. Thank you.
Yep, no problem.
Yes, Kathy.
Never mind. I don't know how to word my question. I'll talk to you later.
Well, okay, but we.
Well, I guess I'm wondering how many, is it going to be broken up? Is there a certain section that will be a higher percentage of the questions will be from one section or not, or is it kind of evenly spread? If there are multiple areas where we really don't know, and we've watched all the videos and we've looked for help and we still have no idea, is there certain areas we should really focus in on, if it's too much to focus on, you know, everything, or is it kind of evenly spread, everything on the review sheet?
So a lot of the topics that we did talk about in this first half of the semester have been cumulative. So I would suggest kind of getting comfortable with the basics like means, standard deviations, finding z-scores before you kind of move on to what's a probability? How do I calculate those? So you really want to start with just the basic things, and then once you feel comfortable with that, then start to expand. But I mean, if you don't know how to find like this first set of stuff, then trying to compute like a confidence interval is going to be a nightmare.
And do you, in your past experience, what percent, or are there any people that just don't finish in the time given for the 2 hours?
I think last semester, then the time limit was actually like 75 minutes, and I'm pretty sure everyone finished and the exam was longer. So you should be fine.
Now, on that point, Linda, and we kind of, you and I jumped around in some of our discussions, and we may want to have a little talk, and it doesn't have to happen today. It certainly can happen tomorrow, but I want to make sure that the exam is scaled for 120 minutes.
Okay.
And that might be fine just the way it is, or that might have us benefit from some reflection on that. So anyway, there's that. Okay, other questions from the students? Linda, let's go back and glance. And again, I know what time it is. We've got just like 2 minutes, but we seem to have exhausted the questions. So let's go back to the PowerPoint slide just for a moment.
Okay.
And go see, I can advance them, and I actually know what I'm looking for. So. Let's just talk about a problem here. And Linda, we talked about some of these. Pick a number, Linda, any number.
Let's go 16.
All right, malpractice. In a study of 1,228 randomly selected medical malpractice suits, it was found that 856 of them were dropped or dismissed. Construct a 95% confidence interval for the proportion of medical malpractice lawsuits that are dropped or dismissed. So you see, in this case, so you want to have a 95% confidence interval. So and this is a proportion. And the reason we know it's a proportion is because it's talking about 856 out of 1,228. So the p hat is going to be 856 divided by 1228. And then we're going to go back to the grace notes. And this is really just plugging things into the formula in the grace notes, because you see this is the confidence interval for a proportion. This is for P. So this is going to be P hat, which is that proportion, plus or minus Z alpha over 2. And this is about 95%. That is 1.96. And then this is the square root of P hat, which is that fraction, times 1 minus P hat divided by N. So you see, this is the formula. The minus is going to give you the lower end. The other one is going to give you the upper end. Now I am going to listen to Kathy's question, but we're about ready to turn this off because we're really almost out of time. Go ahead, Kathy.
Can you remind us what is the p hat and when you see the z with the alpha over 2, what are we?
Yeah, I can tell you the p hat is your point estimate that comes from your sample. The Z alpha over 2 is what is associated with a 95% confidence interval. and N is the number of things, number of data points in your sample. And the Z alpha over 2 is 95%, and that is on your normal table. Now, I know you didn't want me just to rattle off what these things mean, but I would say that what you want to do is, if this is something that you're saying, wow, that's something I'm not feeling comfortable with, I would, number one, I would watch the videos, again, dealing with that. And I would maybe come to one of Linda's GSGs or Tom Topol's GSGs or my office hours, something like that, and say, yeah, I really need to discuss this, these confidence intervals for proportions. Okay, so that's kind of what I think is there. I am going to ask Linda to turn off the recording and dismiss people. Kathy, if you